Hello, should be live. As people are joining, and if you want to say hello in the chat, that'd be great. And I'll probably mention this several times, but if you also want to come on the actual stream, you can. But also, a lot of people just like to talk in the chat, and I'll try to bring up your comments and discussion happening inside the chat, kind of into the audio conversation as well. And while people are joining, actually, let me bring up the other streaming location so I can make sure that we're live in all the right places. But as always, if you want to say you can hear me, you can see me, that'd be great. And we're a minute early, so a lot of people probably aren't here yet. I always like to get the stream started a minute early so people join in, or as people join in, they have actually something live to see. Just make sure I have the right link everywhere too. I'll know soon enough when a lot of people pop in, but I'm like, oh, no one's here yet. But I think we were just a minute early, so people will probably be joining in. How's everyone doing though that is here? I think I see a few people already. And just making sure. Okay, cool. Luma does go to the right one. Also, originally when I booked this event, I wasn't thinking about how it was right after Memorial Day. So it also might be a lower attendance today than normal. That's fine if that's the case. And if there isn't as much discussion, it just might be a shorter stream than normal too. So we'll give a couple minutes for people to kind of come in. And maybe as you're joining, one, it's always kind of fun to see where people are tuning in from, but also if you're working on something, I mean, it could be anything in the AI field, but it's kind of fun too if people have anything specifically that they've done with like image generation, for example, or that you're just interested in doing. So maybe you haven't done it yet, but maybe you're hoping this book or kind of knowledge around this book could help you get started. I'll share these links. I might share them again as well. Again, it looks like a lower amount of people so far. So I'm going to give it probably a couple minutes, see if more people come in. Like I was saying, it's the day after Memorial Day. Everyone's back at work, at least in the US, if you had that day off. I feel like everyone's back at work now, kind of catching up. So might be lower attendance. People might want to see the recording. I'm going to share links in the chat, though. This is a link to the book on the O'Reilly site. And this is a link to the book on the Manning site, which is the actual publication. If you've been here before, you know I have to read through the O'Reilly subscription. But if you have like a library account or even a school account, a lot of times libraries, like public libraries, will have access to O'Reilly, their online platform. So you can actually go read the books usually for free, like with a library card there, but all like legally through the library system. And they have a partnership with O'Reilly. Manning, the direct link, because this is a Manning book, the text to image generator, which is the book we're discussing today. You can use the promo code AI Book Club and get 45% off. At least they said. I don't have any kickbacks or anything from that. They just gave that to us because they saw that we kept reading their books. I haven't tried it out, but it should work. They said there's no expiration for it. And then also, I'll share a link to the books GitHub. So most of the code examples, if not all the code examples, they have available on GitHub if you want to read those. And then also people always ask for the slide links. So if you want to come to these slides, I put them in the chat as well. And you can go around and grab these links again if you want. But most of the slides are really just like chapter titles around the discussion piece. So see, I'll wait another minute, see if people join in. I see a few people here, but no one said hello in the chat yet. Are people watching? Are people streaming in? Is everyone catching up from the long weekend back at work? And if no one is talking again, that's fine. But it might be a shorter discussion. I guess I'll just discuss with myself, which could be fun, but probably not as fun. Someone said hello from Chile. Thank you for saying hello. Now I don't feel quite as alone. Again, if people do want to join the stream, I guess I could share this link now, even though we have a little bit more of the somewhat housekeeping type of stuff that we usually go through. If not as many people are here, maybe I'll just go through it faster. I'll share a link. Let's see. Share a link out on this chat and then the LinkedIn one as well. Let me pull that up. Also, if people are here, actually, a quick question for you too is, do people like watching on YouTube or LinkedIn? I usually stream in both. I used to point people to like the LinkedIn one primarily, but I think people might be preferring the YouTube one. So just an open question out there, actually, if people have thoughts on that. And then let me share a couple of the links real quick in the really just to the book and GitHub in the LinkedIn chat, because I think I just shared in the YouTube chat, and then we'll get going. One more link to share. All right, so I'll go through some slides real quick. Again, it looks like it's going to be a smaller turnout today, probably because of the holiday weekend. So if you haven't been here before, this is the AI Book Club. We, in short, we've been reading a new book every month, and then we discuss online. If you want to discuss in a Slack channel kind of during the month, which I haven't been doing as good of a job as lately, because we've been doing a lot of other events, actually. Almost every Friday, we've been doing like more of a hands-on building and learning type of thing. So you can just also discuss that in the Slack channel. But you can join this Slack channel for Flight, which is like an open source MLOps AI orchestration platform that I work on. But we're just using their group, and there's like an AI book club channel. And then there's one called ML and AI, which is kind of for the AI build and learn that I mentioned as well. And then there's an intro channel too. So if you want to do a more permanent introduction in there, it's kind of fun to see like what people are working on. And then if you want to get more like alerts for all the other events that we're doing, you can join the AI Builders and Learner Luma calendar and kind of keep up to date there. And then a quick thing on the schedule. So this is what we've read so far this year. If you've come to everyone, if not, feel free to pop into any one that you want to. But this month we are reading Text to Image Generator, which is what we're going to be discussing today. This month we're reading agentic architectural patterns for building multi-agent systems, and then we have RAG with Python a cookbook version. And then I'm really excited to read the other build a model from scratch, or build a reasoning model from scratch, which we read the build the LM from scratch by the same author, Sebastian Rashka, I think is his last name. I might probably mispronouncing it. Very, very, very good book. So I'm really excited to read kind of the sequel to that in August. And then this should be fully released by September, which is the vision language models. And then October, November, December, let me know what you're interested in reading or topics around it. We'll try to find a book to read around it. That's what we read last year. We did a whole other year before that. I won't read them all out, but just to give you an idea of kind of the books that we've read, or if these are ones that sometimes people are like, we should read AI engineering, for example, but we already read that last year. And again, what should we read next? Join the Slack channel or let me know in the chat here. Let me know. Oh, and somebody said that they prefer watching on YouTube versus LinkedIn. That's kind of what I was thinking now. But I did put both like in the Luma event or meetup. So if you do like one or the other, you should be able to do both. But I do think people prefer to stream on YouTube. I think I definitely do. So that's kind of where I'm pointing people towards now. And then the format. So say hello in the live chat where people are talking, or I'm sharing links right now. If you want to join, I shared the links. I think I see someone up here. I'll bring them up in a second. And then if you can also message me on LinkedIn. Actually, let me pull up my LinkedIn real quick. And if you want to connect there, you can. It's another way of like joining. If you missed the link, you can message me on there. I'll share this. And then, yeah, we'll discuss in there. And then shout outs. Usually there's more people talking. Like I was saying, it seems way quieter today. But I'll still open it up. Is anyone hiring? Is anyone looking for a job? Any awesome projects that you're working on that you want to share? There's been several times where people have at least gotten interviews. I don't know if they got hired from kind of sharing what they're working on. Like we've been reading books in a specific topic, like in finance or whatever. People were hiring in that field. People were interested in working in that field. And I know they got interviews from it. So Feel free to share it. Again, super small turnout today, I think. But if you do want to share it, you can do so. And then I'll go through the chapter summary. But also, we have someone who joined the link. I'll see if they want to come up and say hello. Hello, hello. Or maybe they just joined to listen. I'll leave you up. If you want to unmute yourself, you can. But I'll keep going through. If you're just listening here, that's cool too. So the chapter titles, I'll just kind of read through them and then we can go deeper into the chapters. And this book's kind of interesting because a lot of this is conceptual, just like a lot of the build from scratch books that I've read, which is really just like the one other one. I think I've perused some of the other ones, but it's like conceptually, what are these things that I'll list out? So it's kind of interesting to maybe talk about. And what I was thinking, what I might actually do, because I don't actually bring up the book and like show their diagrams, because I'm pretty sure that would be like a whole copyright deal. I don't work for these publishers or anything like that. So this is usually like a discussion with people, asking questions or clarifying topics, and we can dive deeper into those things. But a lot of these things actually come from papers too. So I have a couple of them up, but we can potentially like search them and then bring up papers maybe for those topics to actually maybe bring in like a diagram or something. So the book starts out A Tale of Two Models, and they talk about transformers and diffusion, which are kind of two different models in the field. I'm sure you've heard a lot about transformers. You've probably heard a little bit about diffusion models, maybe less though. And then chapter 2, and I guess like transformers have they generate things by sequences, right? So like usually you might be familiar with them probably from like chatbots or text generation, and it generates a sequence of text. They can do similar things with images where you can have patches basically of an image, and that'll get generated. And then there's an attention layer. If you think of the attention layer to words or tokens, but now instead of a token, that token's kind of like a patch of an image, and then it can generate an image sequentially like that. And then diffusion models usually have like noise that they denoise and create a image, in this case that way, where instead of a sequence that they patch together, they kind of have a whole thing and it looks really noisy, and then they like clean that up, and then you get this whole image towards the end. And I know there's things around diffusion language models, which actually might be fun to poke into later. This book does not talk about them, but just going back and forth again on the transformers and diffusion, there are kind of different ways of handling a generation problem. I'm also curious because I know there's transformer object detection. Does anyone know if there's diffusion object detection? That's just like a field I've worked in. So we did like a DETR, which is the transformer object detection thing, a few weeks ago, and I just haven't looked at a diffusion one. Just interesting to think about. And then chapter 2 is building a transformer. So if you aren't familiar, or you haven't looked at some content around this, a good introduction to how transformers work. Doesn't go as in depth as the other build from scratch, because that entire book is around that. So they get to go way deeper into tokenization and stuff. But again, this is like a good kind of high level chapter, how to build a transformer. And then we have classify images with a vision transformer. And then we have add captions to images, kind of showing how you would combine these things. And then we have generate images with diffusion models. And then we have control what images to generate in a diffusion model. And I'll go through the sub chapters, and so just give you an idea more what's in those chapters a little bit later. Chapter 7 is generate high resolution images with diffusion models. And then we have a whole chapter on clip, which is really the most popular way right now of combining the embeddings for text to image, or at least it was the most popular, and I think it's still one of the most popular ways. And then we have chapter 9 is text to image generation with latent diffusion. You're kind of condensing the representation of that image down into a latent space. Like if you've done deep learning before, you have like or like encoders, auto encoders. You have something comes in this case like an image. You put it into like a more stripped down latent space. So you have like an image in there without all the representation, and then you decode that out. So in that latent space, it's much more efficient. Like it's much smaller, and you can actually do like more generation with less compute there. and it can be way faster. And then you have some sort of decoder that can decode that latent space into hopefully what looks like a really good output. And there's different ways of doing that. And that's the book kind of builds upon each other. And then the next chapters after this kind of all talk about different ways of doing that. So then there's a way of doing it with stable diffusion, which is a paper that came out in, was that 2022, 2021? I forget when they open sourced it. And then we have VQGAN, which is a variation quantization. There's like the variational autoencoders, which we talk about as well. And then the quantization part is this interesting thing that I hadn't looked into before, and maybe we can bring up the paper for that. But basically, you can have these representations in your like latent space, and then they get converted to another learned space, like learned representations of images. So you could think of that being like kind of like convolutional layers on an object detection model or a classification model, except for a generation piece. So you can learn how to generate things like curves or what a sky might look like or an eye or something like that. And then you'll have this latent space that will map over to that. And it does, like, technically it won't always be higher quality, but it has to do a lot less compute to get it to look good, because you have the kind of these like saved learned states that you can map to, which I thought was really interesting. I hadn't seen that before. That was one of the big like aha moments for me reading the book, where I hadn't really dived into, I guess, like how the VQGAN or the original DALL-E kind of was implemented, which they talk about implementing in the next chapter, a minimal implementation of DALL-E. There was that open source one that maybe you remember when DALL-E came out, that was like a Hugging Face base. I think it was called Mini DALL-E. They might, and then actually I think they ended up having to change the name of it or something like that, because it wasn't actually DALL-E, but it's how they thought they were doing it. And then chapter 13 is new developments and challenges of text image generation. And that one talks about, some of the newer stuff on the horizon that's coming out, and then also challenges and detecting deepfakes. So like the challenge of deepfakes, how maybe that's not always a good thing. And then they have a whole chapter or a whole sub chapter, and they're training I think it's a ResNet 50 model to detect fake images. And I'm curious how well that still works on today's images, if that's still something that you can do easily with just like a ResNet model or what. Any of these chapters sound the most interesting to people so far? And again, we'll dive deeper into them, and we could do a little bit more of a summary of each one. And I see a lot more people joined, actually, so people might just be coming later today. So feel free to say hello in the chat if you have discussion points around these topics. Let me know. If you want to actually come up on stream too, let me know. Or if you just want to talk in the chat, that's awesome. And I will kind of bring your questions into the stream here. And somebody said, hello from Colombia. Welcome. They said book recommendation for this AI book club is Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. So actually in January of this year, we read the newest version of that, which is by the same author, which is Hands-on Machine Learning with Scikit-learn and PyTorch, which was really, really good, by the way. I definitely recommend reading it. If you want a book that really encapsulates so much of the field, I think it's such a good intro into kind of all the different areas. Like it goes through where the traditional machine learning, it goes with like scikit-learn, implementing most of those algorithms, how they work, like linear regression, decision trees, etc. And then it goes into deep learning with PyTorch, which I think more people are using now versus TensorFlow and Keras. And it also has a chapter on like transformers and some of the newer areas of AI, and a whole chapter on reinforcement learning too, which I don't think the original second edition or first edition of the scikit-learn and with the Keras and TensorFlow one had. So really, really good book. Totally recommend it. We probably won't read the TensorFlow one since we just read this one, and this is the more updated one. But really good recommendation. Totally recommend that people read it. Any of these stand out to anybody? Questions, comments? Otherwise, I'll keep going through some of the stuff, and again, maybe bring up some of the papers too. And I will say, my theory of the people coming back from holiday, most of the people commenting so far are not from the US, I think. Which we had a holiday in the US on Monday. I was saying I think a lot of people are kind of just back to work, catching up, and maybe don't have time for the book club today. So it's a little bit lower than normal. Usually there's quite a bit more people here. But let me know too if there was something else that made it harder to get to, like the meetup was weird or something like that. I don't think so, but there could have been something I missed. Oops, I did not do a top takeaway for this one. That was left over from the last book we read. Cool. So I guess I'll kind of, again, maybe go deeper into the chapters. Since there's another chunk of people here, let me just share the links again real quick. So this is the book. If you want to go check it out, totally recommend it. If you want to buy it, I thought it was really good intro to the whole diffusion model and image generation space. If you buy it from them, again, I don't get any kickback or anything from this promo code, but it's there if you do want it. They say it's 45% off. I haven't actually verified that yet. And they said it should still work. They said there's no expiration date on it. And then this is the GitHub of the book. So the code is actually available in here as well. And then I'll share, a lot of people like to get the links to the slides. So share this one more time as well if people want to poke around. All right. So going maybe deeper into chapter 1. And again, maybe we'll bring up papers since a lot of this is like it's like the theory, and then with these kind of from scratch books, they do kind of minimal implementations, which are really, really good for learning the concepts, but they might not always be something you do in production. It's like you take this and then you would go maybe, I mean, often you'd probably use an implemented version. Like there's the diffusion library from Hugging Face, which has a lot of the different models. Even some of the later chapters here, like will use implemented models from the diffusion library. But then you understand what's happening behind the scenes, and then you can kind of tweak everything that you need in when you're doing image generation in some sort of like professional environment, or maybe you're developing your own model, and this gives you a good understanding of like how you might do that. So chapter 1 was again the tale of two models, transformers and diffusion models. So again, it hops deeper into those differences. I mean, the other chapters go way deeper. This is kind of like a high level of the differences, and talks about what is text to image generation, and how usually this is like unimodal versus, or sorry, this is multimodal versus a unimodal thing. So a lot of times you're just interacting with something that does text inputs and text output, but with a lot of new models, they can take in images, videos, etc. And with text to image, it's taking in usually multiple embeddings, so like text embeddings and image embeddings. They talk about some practical use cases for the text to image models, which, I mean, you can think about like generative media is a big one right now. They also have some really good points too, and you see this in the book, that you'll learn when you implement these things, like other really practical things that you can use, like image similarity search, for example. Like you can do that with Clip. That's really, really powerful. That isn't necessarily generating an image, but you understand how the embedding spaces work for that. And then that's really powerful if you're like massive data sets and you want to be able to bring up just a specific type of data within there. You can do that with what you learn in here. And they talk about transformer-based text to image generation. So again, like we talked about at the beginning, this is kind of sequential. So converting image into sequence of integers and then back. So like I was saying, that usually, depending on the model you use, it's kind of like you can think about patches of an image, and maybe we'll find a paper that kind of has like a diagram of it. But you can imagine it generates, like if you're generating this book, might have these sections out. And I think a lot of the models might be like 1,000 sections or hundreds or whatever. But if you just cut this up into like 8 sections or something like that, like this would be one chunk, and it would generate that. And then it would do the next one as a sequence to it, and then a sequence to it. And then the diffusion models are different, where you can imagine that this starts as like just pure noise, like static on there. And then you ask it for something, and then it learns how to like remove and add static to images. The generation piece is removing static. And then you have kind of an image generation guidance that goes into the neural network that's on that part. And then you'll start with a static image and it'll start looking more and more like this as it kind of cleans up the image. Talks about some challenges, some ethical things too. Are generative AI models stealing from artists? Very still good question, I think, right? And I see more models coming up now too, as like services that are images that only artists opt in, which is really cool. And some of them even will map like what images were used and then pay the artist, which I think is a really really cool idea. And then chapter 2 is again building a transformer. So you get an overview of attention and transformers. Has anyone built a transformer from scratch before or looked at how to do it? This is probably similar to something you've looked at if you've looked at it before. Talks about word embedding and positional encoding. And then it talks about creating an encoder and decoder transformer and then training it using German to English translator. The original transformer, I believe, was created for translation. So you would give it a language. It has an encoder for the input, and it then creates an embedding for that. And then it has a decoder that finds relevant embeddings on the decoding side that match that encoded side, and then generates a response that's hopefully good for them from that. And then we go into classify images with a vision transformer. So the blueprint for building a VIT, vision transformer, converting images to sequences, kind of like I'd mentioned. I wonder actually if there's a paper for like the original VIT. Let me see real quick if I can just find something. VIT paper. Let's see, this might be relevant. I think this might be the original one in 2020. Sounds about right. So when did Transformers originally come out? I think the paper was published 2017. An image is worth 16 by 16 words. Let's see real quick what's in this paper. Maybe there's any cool visuals. I was hoping it would have something on an actual image here. Oh yeah. So one cool thing too is when you use like the transformers for any computer vision tasks is you can take the attention layers and then map them back onto the image and see like where in the image that it actually kind of highlighted or used to understand what was in there. So you can see this dog one. I assume it's classifying a dog, plain one, and what is this one? A snake? I'm not sure, or is it? I don't know. Is it getting the snake there? I can't tell. But it's cool seeing the attention kind of light up on these images and like what patches or pixels they're actually using. Anyway, so the book goes into how to implement a version of this. I'm not sure it's from the original paper, but it talks about it. Downloads the CFAR 10 dataset, which has, I think, is it 10 classes is in there, and I think it's like hundreds or thousands of images that you can use to train. So again, most of this book does go through, implements it, shows it in the code. I shared the GitHub for it too. I guess we could bring that up potentially as well. But it will show you how to implement and then do classification with it. Actually, if I go to, sorry, it's a little maybe jumping around today. Let's see what's in this real quick. Actually, don't remember if there's, oh yeah, cool. So this shows in reading in the data set. I wonder if they have the attention mapped on. Yeah, so this is the attention layer of the detection piece, or what's doing the classification. And then you can overlay it on the image itself. The CFAR dataset is like really low pixels. So it looks really pixelated here, but that's, I think, what the dataset looks like. They're like small ones. But you can see it's actually finding, like, for an airplane, I guess it's looking at the front, like pointy part here, and then like the back part. And that's like what is making it do the classification there. And the horse, you can see it's getting the body, dog as well. Yeah, so pretty cool. And I'll share the link to the GitHub again. And then 4 is adding captions to images. So you're training and using the transformer to add captions. And I don't remember if anyone remembered trying to do this before transformers, like with recurrent neural networks. At least from my experience, it was quite a bit harder. Or you didn't get as good of results. So, but this does kind of basically, it's not using clip here, but it's using, you're training a model or transformer to add captions to an image. So you would give it an image and then would try to describe what's happening there. Let's see real quick if in chapter 4 if they have any good visualizations of that. So you can see this is the original caption from the data set, and then this is what is generated after we do the training. So the children are playing basketball indoors, and then we got the boys playing basketball in the arena. I think both of those are true. So doing pretty good here. And again, this is kind of a minimal implementation where you could add more like epics or training data to this, but it's already doing a pretty good job. And I think a little bit better or easier than, again, back in the day. Like what was it, 7 years ago or something like that? Maybe more now. I don't know, for when you're doing like recurrent neural networks for a similar task, which that still got good results too. And RNNs, might have a comeback. Combining them with something else, you never know. But yeah, this chapter just talks about how to do that, preparing the training data set, creating multimodal transformer, and then add the captions. And we end up kind of with what we saw there. And then chapter 5 starts getting into the actual image generation with diffusion models. So it goes deeper into how diffusion models work, visualizing the forward diffusion process. The forward diffusion process is you take images, like clean images, and then you're adding noise or kind of that static to them. And it's learning like how noise gets added to images. And then when you are doing generation, you're kind of reverse that process. And then a blueprint to train the UNet model. Also, if you're familiar, I think there's another UNet model that came out in like 2015, which is what I think of when I hear UNet. And this is similar. It has a similar shape to that model, but it's a specific one, I believe, for diffusion. So there's actually like an attention layer to it. And so there's an implementation of this built into the Hugging Face diffusion library as well. But that was something that was confusing for me reading about diffusion models using UNet. I didn't quite understand how they were doing the attention layer, but I believe the thing is that this is a different implementation of UNet with like an attention layer in there. And let's see what's in chapter 5 on the code. And again, chat's super quiet today. Any thoughts so far? Comments? As it shows the noising process. Oh yeah, and sorry, they use a term that's not epic. It's like what is it? Time something. Is it in the code here? Basically iterations though. So you can see the more iterations, this is the more noise that gets added. And then blueprint for training the U model. I forget if they do this one from scratch or if this one's imported. And I think this is the output here. So this one goes through where you start building this is a pretty still low pixel diffusion model here that you end up building. But then it's going to go into how to take like that latent representation like we talked at the beginning and how to get higher quality images out of it, which was a big thing, how we started getting stuff that looked really good, because if you don't have it's just really slow if you don't do it that way, I believe, and you would need a ton of compute. So then 6 goes into control what images to generate with diffusion models. And then it goes into classifier free guidance and diffusion models, different components of denoising a UNet model. So it shows like how I believe in this chapter, because I think they do it a different way in a lot of the other implementations that are popular now. But I believe it was in this chapter that they kind of talk about how you can add in noise. And I'm not sure which classification they'll have here, where you can add in different noise as guidance to, or maybe this was the different chapter, the noise piece, but there you can add in like a guidance layer into the UNet. There's another way of like you can add in different kind of noise too that combines outputs. That might be the next one, but I think you see in this, I think this is showing different variations of like the shirts generated, where you're getting now this kind of plaid looking one or different colors. So you're starting to see a little bit of guidance here. And then chapter 7 is generate higher resolution images with diffusion models. So we have the attention and UNet. I forget what DDIM stands for. I have to look that back up. Oh, denoising, diffusion, implicit models. And then we have high resolution flower images as training data set, And then we have building and training a UNet for high resolution models. And then image generation and interpolation. Maybe I'll pull up the code again. Seems like fun to do. Well, there's no other questions. Oh, also, all these you can go run in Colab, I think, which is pretty cool too. So if you actually want to run these yourself and play around with anything you can, this is the original data set that you start with. It's like a high resolution. I think, is this an iris or just a different flower data set? Not irises, I guess. You see the noising process kind of like in the earlier chapters. And then you build a UNet to denoise the model again. The diffusion process, like taking the static, kind of going reverse of what it shows here, where you start with random noise and you start denoising it. And as you denoise that image, you are adding features and stuff to what you want to get generated. And then you'll start getting some decent-ish looking ones just with the diffusion model. But again, we'll see there's other components that they stack into this, and that's when you start getting the really good results. But you can see that going from the more pixelated stuff, you're getting like higher quality ones from this chapter. And then chapter 8 is all about clip. Clip is really cool. How the clip model works. Again, this is kind of combining. Do I have one of the clip paper up? I think this is the original clip paper from 2021. They call it Learning Transfer Visual Models with Natural Language Supervision. So in clip, you're basically, they have a way of combining your text embeddings. This is like what the encoder part does for that, with image embeddings. And then you can combine them and you can like query them and use them in different ways. So this is really, really cool for, again, like even outside of generation. If you had like a whole bunch of images, you want to query like, give me all the images with a dog in it or something like that. Clip can do that, which is really cool. Let me skim the paper real quick and see if there's anything else cool in here. But basically, it learns to combine images and text, so kind of describing what's in that image, into an embedding space. And that's what allows us to embed that information for these like models better. It's a lot of citation. And it goes through, again, the book goes through how to kind of implement this from scratch somewhat. But there's also a lot of the pre-built models that you can take to start using this. So we can look at the code there real quick too. See if they add anything good. So this shows the captions with the images. And then they probably do, I think they might use like a query prompts. Yeah, so it just shows, this is kind of similar to the other, this case they're using it to get captions back out, kind of like the other example. Again, you can see it's working pretty good, but it gives you a slightly different caption than what's in the original prompt. So a lot of cool stuff you can do with clip. And then 9 is text to image generation with latent diffusion. I think I talked about, if you're here at the beginning, where the latent space is basically you can kind of encode a model into a, a denser, smaller representation, and then you can decode that. And there's ways of, so basically you're compressing the information very small and then reconstructing it. And so one of the ways to do this was with variational autoencoders, which I think have been around for quite a bit. I remember using them or reading about them years ago in some of the other image generation books. And I did a lot of GAN work in like 2018 or something like that. And we were using some variational autoencoder stuff to help with that at the time as well, or looking into it. So this goes more into what that is. And yeah, it talks about latent diffusion. Let's pull up their code example real quick. So yeah, okay, cool. So this is kind of a representation of like, this is the original image, and then you get this really compressed image that's missing a lot of the features. But if you have a good decoder for this, then you can decode this image and get a really good looking one back, or very similar. And then there's ways of basically, as the other chapters progress, doing like the diffusion process, like the generation process in this latent space. So it's a lot less features that it has to generate. And then if you have a decoder for that, then it can actually create a high quality image, even though you had done kind of the diffusion or generation process inside of this latent space. And there's other ways, like in variational autoencoders, even before diffusion type of stuff in there, there was ways of using some influence to like add features into it. I think like you would take two latent spaces, add them together, and then decode them. So like you could have like a bird and then sunglasses or something like that, and it would do an okay job. Not as good as the current models of like sometimes adding some features into that latent space and then decoding it together so it would look good. So you can see these are the original images and then the reconstructed images. So they look pretty good. Like there's going to be slight differences, but these ones actually, I think, look very good. You'll notice some of the other examples won't work quite as good. This shows diffusion in the latent space, generating this banana with a cowboy hat, riding a motorcycle. This is kind of what the denoising process looks like. Again, this is in the latent space here, and then it's going to use a decoder to extract out to this like higher quality type of images. You can also modify, like I mentioned, you could do this just in the variational piece before, but it wasn't as good, I think, without the diffusion piece. But you can do this inside that latent space too, and then add things like stripes or variations in the latent space, and then decode it into a higher quality image. And then chapter 10 is a deep dive in stable diffusion. So that was a paper too, actually. Let me try to bring up that paper. I think this is it, 2022. That sounds right. High resolution image synthesis with latent diffusion models. This is the one that came out of, was it Stable AI? And I don't think I've been sharing the links to the papers. Let me do that too. This is the one for the diffusion model. Let me share. Was the other one we were looking at was the clip one. Or this is the clip one. Let's see if they have any good visuals in here. So kind of, you might have the idea from what we saw. You have your pixel original space, and you have the latent space where it's kind of condensed. But they go deeper into how stable diffusion works, which does a better job of like working in that latent space with embeddings, and then a good job with that generation piece. See if there's any good examples in here. Also, again, chat's super quiet. What are people thinking so far? Totally recommend getting the book if you're interested in like going into the image generation space. It does a really good job of describing all these things in much more detail than I'm doing right now. I'm just doing very, very high level summary, hopefully discussion points. The book has like pages of information on all the stuff that we're just poking around at. So definitely recommend getting it if you think this is somewhat interesting. Oh yeah, I remember this being the one that everyone was showing when it came out. Yeah, so they create text embeddings in a specific way. Use the clip. You can see they're importing from transformers, clip text model, and then they're doing image generation inside the latent space. And then converting the image to the high resolution one using a specific autoencoder. I think this was the big thing that was in the stable diffusion part, was a specific metric that they added in the diffusion process that like stabilized it. I forget what it was called. Might say in the summary here. It's hard to remember every little thing, and when you read the book. They achieve new state of the art. I was hoping they'd say exactly what the main thing that they added was. I'll have to find it. But they add one other kind of tracking metric, I think, from within an attention layer in the latent space part that allowed it to be better than a lot of the other people at the time. And then chapter 11 was the VQ GAN, which I think, again, is a variational quantized generative adversarial network, I believe. Training transformers for high resolution image synthesis. I'll share the paper here again. And this was the one that had, I think this is a different paper. So I think there was another paper I had up that had the other thing. So this had they use this thing called code books, which I thought was very interesting. And if you're here already, I kind of described it a second ago or minutes ago now. But they have a thing where, can't I zoom in? They have a thing where you have a thing called a code book, which is like in kind of like a fixed embedding space, I believe would be embedding space. So a fixed space of representations where like on the encoder part, you have this kind of infinite continuous space when you bring in an image and then you're compressing it down and then you pass it to the generator. And with this thing called a code book, you basically have like these learned set of representations that then you'll bring in the encoded information, like an image in this case, and then you'll use this thing called a code book. They'll have these learned representations. So like you can have a bigger one or a smaller one. The bigger one obviously has more information in it, but does like more compute. And then it'll find the closest things from that encoded thing to put as the outcoded part. So it doesn't always have to be as big of a thing like this, but I think they're showing here that like these are items inside the code book here that are like high quality features. And then so if the encoded thing is very close to one of these things, it can actually just choose one of these eyes, and then you'll have this potentially, in this case, like the high quality looking piece be able to come out as the decoded piece. And you can also have, they show low quality features and high quality features. So it could just be like a patch of sky. It could be an eye, could be any kind of piece of an image. Again, they're like learned representations. You don't manually define them. But it's an interesting way of taking like a compressed piece of information, then outputting it from this like learned space instead of you generate it in the decoding step. So you can get stuff that looks really good, but it also loses that information. So it could be less accurate depending on like what you're doing here. But I thought that was very interesting. That was something I hadn't read about before. And so they do that inside of the VQ GAN part. And it goes deeper into what are autoencoders, the need for variational autoencoders and their training methodology, and then talks about vectorized, quantized variational autoencoders, the vectorized, quantized generative adversarial networks, and that's where you start using those things like codebooks. And then the second to last chapter is a minimal implementation of DALL-E, which is pretty cool. So if you remember, DALL-E was one of the biggest generative models that kind of, I feel like, blew up, where people were very impressed with what it could do. If you remember, was it avocado armchairs is what everyone always used to show it off, I think. So it talks about how to implement the kind of minimal implementation of it. And this is different than a diffusion model. So this uses a transformer, and it generates it in a sequence versus the diffusion denoising piece. So actually, we could try to bring up maybe a paper of that too. Let's see. This one might be it. This is maybe a little bit later. So it's like a number 2 version. Wonder if they'd have how it generates in here. I guess not. But this one's a transformer-based one. So if you imagine again this like separated into grids, it's going to generate from like the upper part, and then have an attention layer where it starts generating kind of not pixel by pixel, but section by section, and then keeps adding them together. Actually, they might show it in the code section. And look at that for the VQ GAN. See if there's anything really cool in there. So you can see in the VQ GAN one, the reconstructed ones are pretty good looking. And then the DALL-E one, they might show what the generation looks like in here. I'm not sure. Oh yeah, so this is kind of showing like it's putting these layers together, and you get that fully outputted. So this is like the attention layer of generating image over a sequence, just like you do generate text with a transformer, where you're basically adding that whole sentence back in each time and adding the next layer to it, or the next token to it. You're kind of doing that, but with an image instead. And then the last chapter is the new developments and challenges in text to image generation. Like I mentioned at the beginning, talks about a better DALL-E series, Google Image Gen, which might be outdated now. Google's had so many different generation models come out, I think, just in the last year. Nano Banana, I don't think that was mentioned in here. And then they just came out with a new one the other week that people are saying is really good. I haven't tried it yet, from their Google I/O. Talks about other different diffusion models. Midjourney. Has anyone used Midjourney recently or looked at them? I haven't. They were also really, really, really popular as a really good generation model, and they gave you a really cool tool set of like kind of interacting with generated images and then making them better kind of over time. Challenges and concerns. Like I mentioned, this talks about like deep fakes, and then this shows how to train a model to detect fake images. And then, so this is the actual part. So it talks about it, and then this is the actual part where it'll walk you through how to train that. So again, that was a kind of quick summary of the book. If you think it's interesting, again, go check it out. Chat has been the quietest it's ever been from a book club. So I don't know what you all are thinking or not. Again, this is my bad for putting it right after holiday. Hopefully you still got something out of me. I don't know. Hopefully it wasn't incredibly rambling, but kind of going through the chapters and bringing up some of the high level stuff, some of the high level concepts, sharing some of the papers. The next book, I guess I should bring up the link for that. Give me 1 second. The next book, if you're interested, which again usually is more lively, is going to be this agent book, which several people in the community wanted to read. So this is why it was selected next to the agent architectural pattern for building multi-agent systems. and then RAG with Python Cookbook. And then very excited for this next one in the build a model from scratch, build a reasoning model from scratch. First one by the author, building an LM from scratch was really, really good. One of the best breakdowns I think I've seen from LMs. I have that actually here. Super good book. Excited for the next one. And then I'm also really excited to work more with vision language models in some projects. So this is actually going to be the book for September is vision language models. So this is coming out, I think, next month or July. And it should actually be fully out by September. This one's probably going to be a really, really good one, a little bit different than some of the other stuff we've covered. I don't think we've done a book specifically on VLMs yet, and I think they're really exciting. Any other questions or comments? And we're kind of close to the wrap-up time. Somehow I've talked for almost an hour up here, even though no one else did today. I'll hang out for a couple more minutes if anyone else has like book recommendations or anything else that they want to talk about. But otherwise, I'll wrap up the stream in a little bit. Also, as part of the build and learn series, like I mentioned, it's a more casual Friday stream with kind of the call to action is to hopefully check out a specific tool or topic and build something in that week. I want to do some stuff in the generative AI space. So like image gen is going to be one of them to find out maybe a specific model that would be good to start with. But then I think it'd be cool to also go into like video gen from there, maybe music generation, and then kind of tying that all together. So if you're interested in the generative AI space too, like keep an eye out for some of the upcoming events in that area. Somebody said thanks. Thank you. Hopefully you still had fun, even though like I was saying, I've probably said this quite a few times already, but this is like the slowest or quietest AI book club I think I've ever done in the last. We've been doing this for over 2.5 years or something like that. So so hopefully this is still interesting. And there's still quite a few RCPs for it. So again, I think it was just the holiday piece threw everyone off here. And noted for next time, I should look at if there's a holiday right before or after or something like that. That's my mistake for scheduling this right after it. If you do have any other book recommendations or just want to talk more about ML stuff, join the Slack channel as well. There's still some people hanging out, even though super quiet. Anything else people want to add before we wrap up the stream? Again, any other books or topics? I really want to do a book or find a book on like world models, but I haven't seen one yet. Usually books lag behind a little bit on some of the most cutting edge topics. But if there's a implementation of world models or anything like that that you see, let me know, because that would actually be really fun to do in the build and learn series, I think, as well. And we've talked several times about doing like a paper reading type of thing, which could be more fun because it could be more cutting edge as stuff comes out, but I'm not sure exactly what that would look like yet. And I don't want to throw just another event to maintain, but if people are interested in like a paper reading type of thing, let me know. And maybe we could find some sort of like cadence for that. So what's that? Agentic AI design patterns. Oh, is that the Springer one? So we have this one next, which might cover some of the same stuff. I didn't compare chapters. I think the one that you might have mentioned is the agentic AI design patterns. I'll look it up, but I think that's the Springer one, right? Book. Is it? Is it this one? I've heard good things about this actually, so we could add that to the list. Oh, so no, it's not. Okay, good. Well, let me know. I guess there's multiple ones probably with that title. Let me know which one it is. By Ken Kwang. Let me find it. LM design patterns. Unless he did another one. Was it this one? I'll see if he did another one too, but maybe this is the one. So we could potentially add this to the list. I'll just make a note of it. I'm going to put it in as tentative. We haven't actually officially selected it yet, but insert text. Just keep a note here. I'll go look at it. Oh, yeah, cool. But is that the right one? The LM design patterns? Because I'll take a look and then we could add it back in, and that should be good because we'll have a little bit of a break between like one of the LM design stuff. So that should be good for maybe October or November, December. Some people also have mentioned several times like graph neural networks are interesting to them. And I know that Manning has a good sounding book on it. I haven't selected it yet either, but I don't know if that's something people are interested into, is like graph neural networks. Oh, and I see you sent a message in private chat. Oh, Agentic AI Harness Pattern by Ken Huang. Okay, let me find that and add it to the list. Agentic AI Harness Pattern. That sounds cool. This one is probably it. Agentic AI Harness Pattern. Top 15 patterns. Leaked from Claude Code and Hermes Agent. That sounds cool and very relevant. All right, added that to the list. Not officially selected, but let me go take a look at it. And that sounds like a really cool one. So thank you for the recommendation. It sounds cool. Let's see. Yeah, 15 patterns. I bet this would be good to implement in a lot of your own projects. Harness paradigm, the tool architecture and tool contract, the query agent loop, permission system and safety guardrails. Sounds important. Tool orchestration and execution, content management at scale, multi-agent coordination, memory systems and state persistence, observability and debugging, production, deployment patterns, SDK versus gateway first, hook event-driven automation, the skill system pattern, MCP integration, model routing and provider abstraction, structured output schema, constraint generation. Yeah, this sounds cool. Let's I'll probably add this for one of these upcoming ones. Let me find which month is going to be best for it. But thank you for the recommendation. All right, with that, I'm going to wrap up the stream. I got to go do other work. It was Monday threw me. Having Monday off also threw me off too. So totally get it that other people are swamped at work. I gotta go catch up on stuff too. So thank you for making the time to joining today. Again, come back to another one. Usually there's a lot more discussion from other people in it during it. So if this seemed a little slow or different than what you were expecting, try one of the other ones, and hopefully it won't be right after a holiday. We're gonna go check the next one to make sure that that isn't the case actually, because it's I think late June. So let me double check that. But thank you again, everyone. I'm going to wrap up the stream.